Okay. My name is Dr. Iskandar. I will be the moderator for today's webinar. Today's webinar is entitled Finding Insights in Digital Data, Perspectives from a Data Scientist. To all the participants, please register yourself through the link that will be provided in this chat section that I will provide in a few minutes. So how we go about this webinar, the speaker will be given 45 to 50 minutes for the presentation. Is that okay, Lisa?
Yes.
Okay. And then we follow with 50 minutes of Q&A session. Okay. As an introduction, data science is a domain of study that deals with vast volumes of data using modern tools and techniques to find unseen patterns, derive meaningful information, and to make business decisions. In recent years, data science's popularity has grown considerably due to innovations in data collection, technology, and mass production of data worldwide. Gone are the days when those who work with data had to rely on expensive programs and mainframes. The proliferation of programming languages such as Python and procedures to collect, analyze, and interpret data paved the way for data science to become a popular field as it is today. To be a data scientist, one needs to have multiple skills that includes not just computer science skills, but also skills and knowledge in statistics, mathematics, business understanding, data management. And that includes need to know tools that are relevant to the domain. Before we proceed with the talk, I would like to introduce our distinguished invited speaker. Our speaker for today's webinar is Lisa Lee Chai-Wen. She is currently a data scientist working with Amazon Web Service Incorporated USA. Prior to that, she also worked with a number of companies in the US, also working on multiple data science projects. And she holds a Bachelor of Science in Applied Mathematics and Master of Science in Statistics, both from Hainan Normal University, China. And we are truly honored to have such experienced and knowledgeable speaker to talk about data science today. And without further ado, I would like to invite Ms. Lisa Lee Chai-Wen to present her webinar. Are you ready, Lisa?
Yeah, I'm ready.
Okay, over to you, Lisa.
All right. Nice to meet you guys. I'm Lisa, and I have about 6 years experience in data science field. And my first job actually is started like in US and as a data analytic, like world in marketing, and then slowly transferred to retail, and now in more of like a tech focused area. And my day-to-day, like still like as a data scientist, a lot of times you will say it's deal with data, right? So that's pretty much what I do for the last 6 years. So I will go ahead, start sharing some screen and kind of walk through like the topics of today. Give me 1 second. Can you guys see my screen?
Yes.
Okay, great. All right, let's start from the beginning. So I think, as mentioned, data science, it is roughly like a new word, like maybe in the last 10 years, and same in the US, like in the last 10 years, it grows repeatedly, like in terms of career, and the needs in the industry, it is really high, especially for large enterprise like Amazon, Facebook, or any kind of a phone company, which is also include Apple and Google. right? So those companies really need a lot of data scientists as well as software engineers. So at the first, I wanted to talk about a little bit about the data science careers, what it looks like from my perspective in US first, before we, turn into the use cases. So a couple of topics I want to cover today is, who are the data scientists and what they're doing like every day. And also I wanted to cover who can become a data scientist, what kind of degrees you might need, which area you can focus on based on the degrees you have, right? And also what kind of other jobs, which is in the data science world, because the title can be confusing, especially in terms of career. When you apply, maybe you get in, but you realize this is not the job you're looking for. And how to become a data scientist? I'm sure like with the degree it is enough, but also you need a lot of more of industry use cases, case study, and some sort of experience to get it started. And the last piece of this, I'm also going to talk about a little bit about skill requirements, what you're going to need, and also the degrees. So let's jump into who are the data scientists. So the data science of today is basically dealing with data. The data can be large data set and extremely large, like day to day from my experience, even just from small company to large company, like Amazon, billions, even trillions wrote is just like a daily job. Like that's just give you an idea of as a company as a whole, like what kind of data size you're looking for. Right, structured data and unstructured data is really common in like a data science field. Like you are expected to deal with structured data, which is this data needs to be already cleaned and it's transactional databases instead of like a log level data or like a clan logger level data, which is digital data. And unstructured data could be include like image or like, video or voice. So all of those need some like data science back, like to kind of like translate it back to the data points. So I will say as a data scientist, it's basically a combination of computer science. First, you need to know how to code. And second, you need to know what the models are. And the last piece would be mathematics, because a lot of the time you need to do a lot of calculations, right? This is from my view of like who are the data scientists. I think data scientist is someone who can translate data into an actionable plan and predict the future direction of the business. Because right now, these days, like most business hiring data scientists is actually trying to have them create the model and be able to take the actions and like predict the future of where the business can go. So that's really like a key point for you to be a data scientist. You need to know how to translate data. It could be messy, it could be hard to tell the information, but you need to select insights from it. And the day-to-day life, I will say 80% you pretty much dealing with more of cleaning data, processing data, and 20% of the time you'll probably do your modeling. And there are some certain amount of time you need to like kind of also like talk to different stakeholders and understand their needs and to analysis the whole needs and maybe put them into translate them into a project potentially implemented. So comes to like, as I mentioned previously, there's a couple degrees, especially in US, they're preferred for data science. When they apply, we're like really prefer this kind of degrees, but just, like it's not limit. It can be you from like learned art and then one day you decide comes to data science after you do like a whole boot camp, you can. But here it's this least if you right out of school, like you can actually maybe get a job right into the data science field. First, I will mention like a data science for sure, specifically for data science. Mathematics, you will be good at finance, word, computer science, you will be good at coding, because in data science, you require hard coding. It's a tool, but you need to know it. Statistic comes to the models, machine learning models, all the like statistic based models, time series, all of those, you need to have an idea to be able to implement data. So business analytics is actually another field is really welcome, especially in the data science field. It can be like MBA degree and also kind of really only focused analytic field. So this is more of, those kind of people has more of like a business driven idea. They can actually, like come up more strategy based on the data they have. Software engineer, a lot of the time they will probably just do software engineer, but that could be an option too. So comes to Korea, I mean, there are a lot of websites for you to actually, like apply through, for like, especially in US, Glassdoor, which is this website, it is a really popular website for us to check everything about jobs, even the salary, interview questions, benefits, and everything. Like, for example, Amazon, right? Like you can have an overview of, and you can see the rating and all the details of each different categories. I won't really go deeper than that. So it comes back to career. There are a couple like different categories in data science careers. So there are data engineers. There are like architecture also. They're basically focusing designing the database and also build the data pipeline and also do the ETL jobs, loading the data, transform the data. Sometimes they also do the cleaning and make sure the framework is working and auditing the data. So that it's a group only focusing on the data side, like a cleaning the foundation for you. And also there's another group which is like a business analyst and the BIE, which is similar to data science analytics, which is the field I'm in right now. Basically, what we do day to day is providing data insights, business insights. Let's say there's a new feature launched. You wanted to make sure this feature is actually bringing more like a traffic or like click-through rate is higher. So that way, this implement the feature, which is the company spend a lot of money to develop, is actually worth it. You probably need to design an A/B testing for them to be able to make sure this is working and to prove to the leadership this is working. So comes the dashboard, that's just a functional, operational like a tool internally for them to see the insights and share the reports. And also system design is more for BIE, which is what I'm sitting in right now. It's kind of just similar to data engineer, but you need to lay out the whole data structure, what you're looking for, and implementing it into the system. Because a lot of the time when you have a data idea, and that shouldn't be the end, that should be the beginning, and which means you need to implement your idea either through marketing or either through the website or app, whatever the end it should be implemented back to the business. So it comes back to the machine learning engineer. Specifically, this is only focusing on machine learning. This is narrowed down to the models related to machine learning only. So you day-to-day probably do a lot of deep learning, reinforcement learning, AI stuff. All of those will come to the machine learning like field. And the last piece will be marketing decision scientist. This is more of focusing in the marketing field, and day to day, they make the decision for business. Especially in Facebook, they do hire a lot of data scientists like this. So the last piece. next piece, we can talk a little bit like what's the difference about like this. And I think I already mentioned, for the data engineer piece, we'll be more focused a lot for ETL data pipeline. And for the data scientist field, you focus a lot for A/B testing, classification, which is model related, or segmentation and forecasting. Comes to machine learning engineer, also mentioned deep learning, AI, machine learning, and a lot of the time you need to work directly with engineers. So ICEs, the people who actually build the website, build the game, maybe build the app. And data scientists still strongly needed is statistic, Python, SQL, and R. So this is 3 tools you need the most, I would say, as a data scientist, because most of the time implementation in the real world is using Python. SQL is for you to actually be able to pull out the data. So a lot of the times the database's backend is actually written in PySpark, and you have to probably use the SQL, or like they're being written in SQL, that's possible too. It depends on data engineer preference. So you need to put quite an amount of data, use that first, and be able to plug into Python and to utilize it. Same for R, and R is my personal preferred tools too, in terms of quick analysis. But for like development or implementation, we have to use Python. So how to become a data scientist? Here it's a thought I think I would like to share, like just, like there are a lot of free tools and resources for you guys to use. If you're even like, let's say the 3rd year, 4th year of school, and you're probably looking for some more of like a case study, and here you got a lot of like different courses. So this is free, like if you sign it without a certificate, you can get everything here for free. And also this one, I actually checked, is a little pricey, but this one is pretty cheap. And also you can get a lot of courses related to the case study. And the last one I use a lot is this Coursera, and you can get a couple of certificates here. Especially, I will say, if you can get a data engineer with Google Cloud, IBM Data Science, it's like, I think the cost, it is fair. And if you can get a couple of certificates from here, you're pretty much good to go for your career. And comes down to, like the skills of a data scientist, right? There are a couple different kind of skills might needed, like if you want to get into the world, or you're going to develop those skills as you're working as a data scientist. So technical skill, as I mentioned, Python, R, SQL, SAS, not really a lot, but I know back then when I was a student, that's quite a thing. And the TensorFlow, Hadoop, that's more of a deep learning. You need to know those packages. And comes to the statistics, I will say hypothesis, which is A/B testing, you really need it. Regression, logistic regression of those models, you will need it like really often. NLP, it is another thing really popular right now. It's just analyze the natural language processing, right? Basically analyzing words different, maybe based on different languages, trying to classify different words and categorize them. So under this, there's a lot more deep learning also, just really like in the industry, it is really needed, especially for the product field. Machine learning, reinforcement learning. Reinforcement learning, I will say, even in US, we don't really use that a lot for the business side. I would say maybe recommendation side use it, even that a lot of the time it's just kind of can be complicated and cause some like errors. So depends on the implementation, but I will say Amazon app itself for the products, we use reinforcement learning. And the business cases, that's another thing you probably will be asked during even an interview. It's just like they provide you some cases and you need to answer based on what are you thinking, right? So if you ask how you do a sales analysis, right, which segments you're going to look into. So all of those kind of comes back to how you think, what data you get. So that will lead you to a direction of actions. So last piece, I would say visual and logical. So visual, it is really important for us to present data because stakeholder, the people you're communicating with, doing the work, a lot of time they're not really sensitive about data. So you will be a rule actually translate those data or visually translate those data for them to understand where the insights are, highlighted insights. And also for the logic part is for you need to be a good data scientist. Probably a lot of times you need to think really logically. What's the step one? What's the step two in terms of what you want to get to the end, to the model, and what your end product is. So quickly go through this industry knowledge. You might need to know that this is just for my personal experience, right? Like the whole thing is just from my perspective, and this is my personal experience. Where did I stay? Where did I work? This is kind of the skills I had to have as a data scientist in industry. So like a data analyst, reporting fundamental, all of those you can get maybe like from day-to-day learning or like from use cases. And reporting, I will say you can get from like a Tableau and Power BI, which is the main tools you have to know, like to do the reporting. And digital marketing, you would say like SEO, SEM, display, email. I will go a little bit deeper. Like SEO is kind of a search experience. Let's say you get on Google and you search something and there's a ranking, right, based on what you searched. So help to optimize that. You as a data scientist, sometimes you'll be asked some question like that. So for SEM, similar, this is paid search experience. Let's say you search Amazon and the number one pop out, there is a corner, left corner, it says app, which is get through search SEM, which is we pay Google and then they're marketing for us. So that comes down to like the budget, how you can actually optimize the budget to the best cost. And you need, as a data scientist, you need to validate how much budget you need to put this keyword with versus another one. Same for display. It comes to website, you probably see a big like thing you just saw yesterday from previous website. That's display. Email, we receive different emails every day. So this is all kind of like basic knowledge, I will say, depends on what industry you're gonna get into. And also Google, Adobe Analytics, Marketo, this is another three, I would say, really important too in the industry. Everyone knows Adobe. Marketo is kind of a source of data. You have to get it from the website marketing. Salesforce is another big company, SAP for finance. And Salesforce holds a lot of CRMs, transactional data, which is most of the company working with, even Amazon. And technical knowledge you might need to know. So FTP, EDI, same, like it comes down to databases. You need to kind of have a foundation knowledge of those automated tools, how you connect it through API. Comes to that next level of, since you're running code and you need to be able to kind of manage the code, share the technical tickets. So GitHub, Bitbucket, that's the tools you can share the code through the organization. And bigger company, larger enterprise have their own internal tools. The third piece will be the databases, right? So for the databases, there's this really a lot existing in right now. Like it's all cloud basis because comes to even 10 years ago, everyone just used like a server-based databases, but now everyone, basically most of the company in US are actually using cloud-based services. let's say AWS. That's where I like working for. So our EC2 is one, S3 bucket, Redshift. All of those belongs to Amazon's AWS. Microsoft SQL is another one. Azure Ender is a cloud-based. Oracle, I think they're working on a cloud-based, and they're also IBM DB2. So there are a lot of them existing. And it comes down to the technical, I think I mentioned for a data scientist, you need some knowledge of modeling and maybe something like this three, I will say NLP recommendation, image recognition. It is the most popular or the most needed machine learning engineer skills. Okay, so I wanted to say, what sets the data science apart? So a lot of the time, like data scientists, especially for like, software engineers as well, a lot of times they're really deep down to the code or like to a really small concept, but forget, what are you actually thinking from the beginning? Let's say you try to design a project which is recommend a product for each customer. So if you think like what is the best way to provide it at, you probably go 100 steps in and you think, oh, this is what I'm gonna do based on the models and predict these products. But if you can take a step back to think, you know what, maybe this customer already have digital touch points. Why don't we just use some of that to actually predict what they're gonna buy? And something like that. It's just, what I'm trying to say is sometimes you don't need models to tell a story. Sometimes the data is right there, right in front of you, and you can tell directly from the data. So that's another thing, which is a lot of data scientists, I would say, in the field are struggling. It's just, we always want to use model. We always want to do machine learning, but comes to the end, it's hard to implementing the machine learning. In fact, if you can't help your stakeholders understand like the basic knowledge of each product or like the area they're focusing. So think big, think for everyone, instead of just thinking of general models or like small things into a specific area. Curious and deep dive. So you always need to curious. If there's a let's say compare with yesterday, if there's a huge revenue increase, or let's say daily revenue is $1 million, one day increased 1.5, you're gonna need to deep dive into that. Why? Because you can consider that, yeah, maybe yesterday someone bought something really expensive, but since the trend maybe tell you a story historically, it didn't happen. So you need to kind of understand, once you see this number, you need immediately have an idea and to starting the checking. So that comes to like data sensitive. Maybe a lot of like stakeholder or leadership, they're not sensitive about the data. They see that there's traffic increase. They can't really tell, but you need to be able to identify right away. So that's how we identify bot traffic, so some suspicious traffic coming through the website. We need to be able to have an alert for it instead of, you have an alert for it, and then later on we can make sure this thing like this doesn't happen. And I think the piece is a project ownership. It is more of like data science is always lead the data science projects. You own your project, and a lot of the times you drive from the beginning, including from pulling the data to the end of launch the project until the engineer takes over. And I think I mentioned that the data science career grow really fast, and now it's cloud-based. And it comes to the another important side, I would say, like, how is the data science the salary looks like, right, in US? And in case you guys later on, wanted to apply to data science career and in US, you have an idea, you don't get like low, like a range or something like that. But also like the Glassdoor, as I showed you guys, you can search through like what is the area looks like. Even this, I will say this is actually in more of like low range entry level pay for most of the data science in US, because the needs in US right now, it is really high. So most of the company paying higher and higher, I will say, every year. And supercomputers. So we know like there's a lot of data like everywhere. So I wanted to show you like how actually grows in terms of data at, from the supercomputer data like perspective. So this is one word data. I will also like give you the link at the end. This is open source. You actually can get a lot of data sets from here for free, and you can do the analysis from them to have a better idea of like, build maybe a case study around it. So when you have an interview comes up, you can use it. So comes to the, there's so much data, there are needs for data scientists, and how the data science career looks like, right? So here it just give you an idea of how you can climb this career ladder as a data scientist. 0 year junior, 2 to 5, 1 to 2, and 5+ senior, 5 to 7, and anything 8 year plus will be about, principal, director, VP, and chief. And how to become a data scientist comes to the last piece, right? So first, you can get a related degree. I won't really say like most of the job description won't really mention master degree, but they prefer you have a master in a related field. And the second piece, you will need to develop a technical skill and do case studies. And the third piece I wanted to just like, especially it works in US, and I'm not really sure outside of the world, but if you wanted to like apply a job, you can actually reach out to the people through LinkedIn and get a referral. And most people really, because LinkedIn is really a platform, most people have hundreds to thousands of connections. They like to actually grow their connections, so they will accept you. So if you can get internal referrals, that's the way to go to get started. Because if you apply through the website, I will say that it's gonna take quite some time for them to get back to you. Same, prepare 2 months, something like that, to get all the like lead code prepared and all the code case study prepared, and then you can negotiate offers. So, okay, I wanted to jump, before we jump to this field, I wanted to see anyone got any questions in terms of, data science careers, especially like in US, and if you has like, like some thoughts on that. Okay, I think I can maybe leave that since we're kind of, high on time. I wanted to quite quickly maybe like leave that time to the end. So it comes to data science works, I wanted to kind of show you guys what the data sets we were using, what's the case we're having, what are the open data sets we have, right? Comes to data driven, I think everyone knows data science deals with data every day, and you need to come up with a strategy and reshape them to the metrics you need for the models. So a couple of different kind of data sets I want to mention here. So data paths comes to like, I know I mentioned it like a digital, but even inside of the digital, there are a lot of different categories under it. Let's say social media, marketing data, website app data, a different, and image, audio data, which is you translated from the video and voice. And also transactional sales data, they all store kind of like in the also in the system, like most of them, a lot of times in Salesforce, the CR and the customer profile, and also at the end, the finance accounting, which is a lot of it is actually invoice data. We We can jump into each of them. I can give you an example. Let's say social media marketing data. So this data set, oh, I think I forgot to change the link. Yes, this data set can give you all the marketing information. So you have, usually you have all the timestamp, you have all the like channels, where which channel they're having, rich medium means display, and what kind of like interactions, impression means like you see it, but you didn't click on it. So those kind of information you will see pretty much day to day if you're working for a marketing firm. And a lot of time you need to translate this raw data into either into a dashboard or into kind of a strategy for them to understand where they should target next. Or even design A/B testing for certain products to make sure, or certain links to make sure they can to get a higher click-through rate. So here's this couple metrics that I mentioned is really important for most marketing firms. The click-through rate, higher is better. Like we expect most of the people click through, and PDP wills to purchase, which is this a funnel metric, means from the detail page, whether they actually intend to purchases. Last peak, like total unique visitors, there's more of a general of metrics. And of course, conversion rate. Conversion rate usually is from the upper funnel to the deeper funnel. Upper funnel could be total visits divided by final purchase, or like from the last fulfillment page to the final purchase. And come to the website app digital data. Here is basically every app you're using, website data you're looking, every place you click on has a tracking, which means everything you touch, everything has interaction with human touch points, it is actually being tracking. Let's take a look at what it looks like. So again, most of the data, even it is raw data, it's still kind of a format in the structured format, because most of DE or engineers will actually get it ready. So here you can see like all of the data here. It is, you have all the page height, which is one click will have one row of it, and this is where you entered. And this is what's the URL. And referral means that's where you come from. You probably come from Google, you come from like a Firefox, just any kind of like a website, even linking directly to here. It will have the tracking. So let's see. Oh, it's not moving. Sorry. So we also have the page classification most of the time, whether it's a detail page, whether it's what kind of page are they. So all of those information you will have it in a website or app metrics, like a data set. Comes to transactional or sales set, it will be more of looking like a transaction. You go to the store, you buy a product, and they scan it, you get one transaction. Sometimes maybe it comes to an aggregate level, which is one receipt you have will be one transaction. Or you buy something online from a website, that could be a transaction. So those data are really common too, because they're the sales data, that's the real purchases, and most business cares the most. They want to know like what product people are buying, what kind of activities they have. Like, comes to product, there's another thing is association products. Like if they buy this product, and what's the chance of buying another product? So that will comes down to data scientists to do the deeper analysis for them. Let's take a quick look of this transaction sales data. Yeah, I think this one is a little large, because a lot of the time sales data, they have like maybe 20 like hundreds of columns of a weekly data. That's why sometimes it's really slow. Let's keep going. So comes to the demographic data, which is another thing really important for us to utilize so we can better target the consumer, right? So demographic data will be more of like this information, what I'm showing over here. What's the gender, what's the age, what they're buying, whether they have a car or not, are they traveling, do they like coffee? So those kind of things give you an idea of like, what kind of product you can target them with, where that interest lays. So also that includes geographic data. It could be like, like where they're located, what the address looks like, or like which store they're wanting. So all of those information you can consider geographic information. And also this is more for location targeting. Let's say you're listening Amazon Music, and on the way you're driving, and suddenly there's a Amazon ad pops up in your phone and saying, like even when you listen to music, and the Spotify or Amazon Music will suggest you to go to that kind of like, you go to McDonald's. It's based on your location and right there, and they know you are within 5-mile radius of this locations of McDonald's. So this suggests you to go there. So that's kind of targeting. It's called hyper-local targeting. So I can show you what the data sets looks like. Let's see. I think I have one open. No. Yeah, most of the data sets are a little slow. We can go back to see it later if we have time. So comes to that, like you have enough user data, then you need to build the user profile, which is this is one of the another job most of the data scientists really need to do. Here rely on a lot of like metrics, mapping, relies sometimes on classification. It's kind of grouping your consumers based on their portfolios. So that way, in this group, a female 20 to 35 has a kid, you probably target with them, sports product because they like exercise, they mentioned, or like they have a kid, you're probably gonna target them with the kids product. So something like that you need to know, like that way you can sell your products better. Comes to your timeline, it's another thing for sales use a lot because the sales like they wanted to predict the future direction of the business. That's another thing. If you work for the finance department, tax department, which is sometimes we have to do the predictions for them all the time, which is basically use time series a model to kind of predict like next quarter or yearly like revenue, even product sales, transactions, subscriptions, things like that based on like historical information. Sometimes you have to use the digital touch points or transactional data, just trying to predict like, add those layer of information and you do a regression and then to predict the future like revenue looks like. Okay, so I wanted to come to the case study. So I think we're kind of tight on time. I will quickly walk through some of them, and if you have questions, we will leave a couple time, like some time at the end. So how do you learn case study for free? Online courses, there are a lot of them, and interview questions, lead code. Here has the link. So I will share this presentation with you guys so you have all the links later on so you can kind of play around. Okay, so comes to the case. I list a lot of case here, but this is just the case I did, and I consider maybe they're interesting, and also have this link for the GitHub, you can link through it and check through them. So I don't think I want to go too much detail, but I can pick one or two to kind of help you to understand what they are. Let's say the first one I mentioned, hyperlocal customer distance and the sales shares analysis. This you need a calculation, which is based on, let's say, 5 mile radius with each store, and your customer within zip code 10 mile radius, and you calculated those customers, and based on their address, honestly, we have those data based on their address, and to see whether they follow into your certain radius. So to understand what your target radius should be, which means if your sales within 5 miles already generated 70% of the revenue, you don't need to target, like a low, or let's say 5 mile radius, you already target 90%, you already generate 90% of your revenue. You don't need to target anyone out of that radius. So that's another thing. And the scorecard model uses your logistic regression. This was first doing for a finance company, which is they need to kind of, based on all the features of each customer they have, to needed to give idea of the proof on the loan, yes or no. So this is a logistic regression. So all of those case studies, I actually have them in the GitHub. Most of them has code there, and you can just take a look, and you can always email me if you have any questions. But something like another piece that I mentioned is the automation. So as a data scientist, a lot of times you need to automate your work as well as help other people automate their work. So automation piece is also really important. Let's say the bad news detection using NLP. That's something like if someone leaves the bad news, it could be really bad for the product and the company. You need to detect that and have customer services reach them back as soon as possible. So yes, comes to the real cases. I think I have, so I will quickly walk maybe one or two of them. So for the association rule, I think I mentioned, what's the chance they're buying? What's the chance of buying different product in the same transaction? That's what this rule about. So this is analysis of purpose data for one of my company. And basically they're trying to understand, if you have like this product, what's the chance of they're buying another product? I know the support is a little bit low, but some of the confidence are really high, which means if they go to water park, they must really high chance they will buy Zipline. So the percentage here is low. It's just we have like 50K of products. It's just too many options. So that's why when it comes down to the percentage of total transactions, it's probably low. But this is giving us pretty good idea of, like where they can actually suggest if they buy this water park, we should suggest the Zipline. So this is an analysis, or you can say this is actually model based. A lot of time you have to do and to provide the product team to help them understand how you can improve targeting. So comes to the, okay, this is raw data. Okay, so I guess this I can link it in the website, in the slides too. It's just trying to, this is how you can do automation for all the digital touch point reports. And I have another link which is customer portfolio. What you can do to build like a customer portfolio. Here is a good template because this one is basically using public data. And we did back a couple years ago, I did the whole thing because it is more for like we would page the the account trying to get the business. So this is everything here. It is more from a public source, which is Sense data. I will show you at the end. So I will link it here. You can walk through it, but pretty much for the analysts, there are a couple steps you need to do and get all of the metrics, classification done until you can share with the stakeholder or the client. So comes down to the last piece, right? Like you can email me. I have a link in here, a GitHub over here. And also, just, like try share internally, that's fine. But most of, I would say 100% of the data here, it is in industry data. There's no modification or anything. So you can use it personally, but just try not to like share too much. And at the end, I also share with you another link, which is this like presentation template. So if you wanted to build a use case around, so you can go to this website, use something like you like as a template. All right, comes to the questions.
Okay, Lisa, is that it?
Yeah, I think I have to cut something over here, but all the data, all the code, and all the like links are here. Maybe I can share with you this whole presentation, and you can share with everyone.
Okay, thank you, Lisa. So we give Lisa for a breather because she's been talking and giving too much information, which is very, for me, and I think also for the participant, very enlightening, especially in a data science and data analytics sense. So so now we will go into the Q&A session. So I found out that there are a couple of questions already in the chat session. So while we give Lisa a breather, a few minutes, okay? Now I open to the floors to question, to provide any question. If you have any question, just write down your question over the chat section. So if time permits, I will pick up a few questions. If there is a very few questions, maybe we can address all questions. But if there are too much questions, maybe I just pick a few lah. So okay, if for
no worries.
Anybody interested who wants to know more, can you please write down your question over the chat section? So
okay.
Yeah, we just we give a few minutes for the contestant while actually there are a couple of questions from two of the participants. Maybe you can go through that question first, Lisa, and then we at the same time we wait for other questions to be.
Sounds good. Good.
Yeah.
So first question, how is the progress measured in your daily work? So in the daily work, as I mentioned previously, as a data scientist, you have a structure designed based like, what your role gonna fit into. What I mentioned, it is a lot. I know like here and like this industry and that industry. But if you come work as a data scientist for Amazon, let's say I work in specifically revenue-driven sales service team. So basically my progress be measured based on the projects I have. Let's say I have a project is related to recommendation on the site for product. So I will be measured based on that, like how the project I predict I'm gonna finish this project in 6 months, and like how long it take me, how much progress I have to plan the whole thing up. Same like we have even that like we have multiple projects at the same time all the time, so to me be able to measure it, and that's just a small portion. And also aside from that, you get a lot of ad hoc questions from different groups. That's another portion of your work. And also you have to devoting your time perfectly through the day, trying to make sure you can get your project done, and as well as some random questions, if that makes sense. So yeah, I know for software engineer, it is more focused in coding, that's it. But for data scientists, it's a teamwork. A lot of time you have to jump into meetings, answer leadership questions, stakeholder questions, because they're not really familiar with data points. You need the one to be the leader on the data. So whatever you say in terms of data, they believe you. That's the good part. The bad part is that you have to constantly communicate with different group. You like a middle point between engineer, business, PM, and also leadership. That's across the whole industry pretty much. How hard to settle in US, especially for Asian? I think that's another thing. Like as I mentioned, how to get into apply job in US, right? Like you got a degree, you're solid on coding, and you're good with use cases. You knocked all the leak code. So get a referral from website, LinkedIn, and you apply, they approve, you move here. It's just that. Like it's not hard. I would say, like especially in I might know, like in especially in Asian countries, maybe like we're more concerned safety in the US and a lot of things. But from my personal experience, I haven't really get anything like bad ever happened to me. I'm pretty much enjoying here, and I would say like. Yeah, I would say like it is pretty comfortable and easy to get settled here. As long as you got a job, you get a visa, and this visa will allow you to actually apply for H-1B visa for 3 years, unless you get it like during this 3 years. If you don't get it, you maybe got a problem. But there are a lot of people actually working on Amazon. They be transferred to Canada, and then in Canada you can get a green card right away. I mean that's a lot of information, but that's really just the thing, like how you actually can
maybe
make it
he
work.
should consult with the immigration or whatnot for this matter, I think.
yeah, I mean that's just like that's a thing like too for everyone in Amazon or like everyone in US. Most of us software engineer or data scientists are actually immigrants. And can this work done remotely? Yes, I have been working for remote for 2 years. It just like never really get a chance to go to office really. You can, but it's just not really required. And my boss is not even in the same city as me. So I don't really go to the office. Can be done remotely. And a lot of my coworkers, like from India and China, they go back to their country for 2 or 3 months, just working remote. And what data visualization tool you're using? Me too. I would say like inside of Amazon, we got a lot of things. We have quiz sites, we have some like we use Quip, but that's just Amazon thing. But for wider scope, I would say Tableau is number one. You have to just really a lot of job interview will ask you a question related to that. Power BI is another one, but I think Tableau is winning this year's. So I would say if you have to choose a data visualization tool, choose Tableau now. And also, like in Python, a lot of time you can use Jupyter, just kind of, clean the data and also visualize it. You can visualize everything in Python too. And so a lot of times when we do analysis, like we want to present it quickly, we use Python. Provide training or your self-learning on the tools. Training, there are a lot. I think I linked a lot of links for you guys for the courses. All those courses has a specific focus. Let's say you want to learn visualization, you search Tableau, there are hundreds of them. And then you learn from them. And I also do self-learn because for me, I feel like a lot of times watching videos, it's just like make more sense for me to just try it out. And if I have a question due to the process, I will search and even maybe watch a short video. That's my way to learn. That's how I actually catch up really quick, basically for most of the job I landed. Which data visualization tools should be focused on? Oh, okay. I think I mentioned the Tableau. What usability pointed to use learn digital for beginner data science? I think that's more comes to design, right? Like when you wanted to design the visualization, your dashboard, let's say you need to have a better idea who is the audience, who are the audience is the most important thing. Let's say you make an executive dashboard, you can't really put the really detail of like each like website or app like a line information for them because they don't really care. They're more of caring the revenue, like you need to make it more visual. You're doing year over year, year to date, months to months, comparison percentage. You need to calculate the net gap between different revenues and trying to tell them, what, with our team, the revenue grows. Something like that. It's more based on audience, and you need to structure each section for the dashboard better because that way they can read it better. Audience is number one. And also be interested to know roadmap for future direction of the data science, how along with AI going forward. So for the roadmap, I will say like the direction of data science, right? Like I think I mentioned like how you can get to, the path to be a data scientist. And the future direction of data science, I would definitely say it is really growing. But there's a couple sad facts about being a data scientist. I think I didn't mention that. It's just your own projects, but you own the data science projects. A lot of times the big piece is being owned by PM, product manager, which is they own certain piece of the website. Let's say you go to a website and you buy a product, and from the product detail page to product purchase page and be owned by one PM. Or maybe by product categories. Let's say this is self-service product or SaaS product or server product. So those kind of things being owned by certain owners, you don't own them. So a lot of times you have to fight or have to actually trying to fit yourself into certain category to be able to provide your project for them to be able to implement it. I think that's the struggle piece. But again, like that doesn't really influence of the like direction of the data scientists, because as long as there are products, they have to have BI support, which is data science support as well. So basically every product team has a group of people working on like data science, either data science, BI. Basically a lot of time, data engineer team, BI team, data science teams kind of together. How be working along with ML AI going forward? I think ML AI is already implemented in most of the company. Either they're probably not really using directly, but they're using an app directly. Let's say Amazon developed a lot of AI or ML like related products, and we provided those products, we sell those products, and people use it directly. They don't really know what's going on inside of the box, but it is owned. I would say this big AI ML pieces is owned by majority the big companies, but small companies are actually building up where they're selling to us or like sell on our platform. That's why there's Amazon Marketplace, which is you can get try all those products for free, and you even can get free data sets. Those data, I think I forgot to mention all the data sets for you guys. But anyway, there are a whole list of the data sets I provided. All of the data there is free. And even in Amazon, like the data sets, you can download them directly. So you can play with them.
So, Lisa, are you okay to answer a few more questions now in the chat session?
I think there's two more, right?
Yeah. I think we'll stop until there. There are two more questions, okay? After that,
okay. All right. I will just answer these two more questions. Let's say, what would you say is the biggest challenge to be a data scientist? I think like from my perspective, as you can see, I'm quite like a lot of time I'm excited. When I first get into this career, I will say I'm really excited about it because data is just something can really make me feel like it's fun. You know, I can make story out of it and I show the people, okay, here where you can grow, here where you're doing wrong. So I like the experience being a data scientist. But again, as I mentioned previously, the challenge here is visibility inside of a team, or like the impact you can be done in terms of implementation, right? Like as mentioned previously, like a software engineer has pretty much a really clear path of the career. They just like launch this website and that's the end product. For us, you need to working with different groups and to be able to implement the ideas and educate your stakeholders. Another challenge, I would say, because they don't really believe in your black box models a lot of time. So how you translate your model to an easy understanding thing, that's another challenge. You should consider all of your audience doesn't really know anything like about model. So that way you can actually make them like, you know, feel comfortable and then accept your project, if that makes sense. Looking that most of us here in academic environment with your encouragement, I mean the current trend in the field. I think the new technology trend in the field, it is driven, especially in big companies like us. We have a lot of applied scientists, which is specifically for research. So those type of group of people, most of them are PhD elite. They really like to hire PhDs, especially post PhDs. It's just for them to focus on the research, you know, like what's the most recent technology we have, or instead of a technology, I would more of a saying method, because a lot of the time I think there are a lot of really especially like machine learning back to 30 years ago already exists, but nobody really utilized it, start using it. Same thing for the applying data science. You need to do research, you know, what is the best way for recommendation? You know, what kind of technology we should bring in? Is that why the reinforcement learning didn't work as we expect? So there are a couple rules, I will say, specifically focus on the academic environment, and they will publish papers, use industry data directly from the Amazon or like Facebook. They publish papers all the time. So I will say it is pretty common still, like in the industry. So with them in, and then that's how they can, if it's working well, like with their method, same thing comes to the challenge of data science. They need to convince engineer leadership to implement the ideas, or they need to make sure this general. Another thing is about an academic thing. So I will say like educators, it's not enough, or your output from the models is not enough. Be able to implement your ideas. More likely you need an A/B test to be able to tell them your thing in the real world is working. So that's the way from academic to implementation, if that makes sense. So I think.
Okay, Lisa, there's one question that I got personally. I think coming from the this is one last question. The question is, what is your opinion of data scientists in helping the global pandemic?
For the global pandemic, honestly, I think it's advantaged like a data scientist, honestly, because especially in US, I'm not really sure rest of the world, but especially in US, all the business basically retail business, basically a lot of them being killed, right? Like really like bad in business. So that forced them to transform their business from the retail, from the physical to online. So when they build online, there's a lot of resources needed. As I mentioned, like previous, like a marketing side, or like how you do the marketing, that all of those actually comes to the strategy from an analytic perspective. So pandemic definitely increased the value, the needs for data scientists, or even for the analytic field as a whole.
Plus the availability of the data also really helps the data scientists, right, to help the pandemic, right? The availability of the data sets of
I think like from research side, I actually was before I was also working for huge hospital groups. They have to predict, COVID like situation, and that's what I did, is just do the prediction for like the COVID cases and the pandemic type of thing. So I think like, I think there's bad and there are bad things and the good things about like how like data science actually like doing good for pandemic. I would say like it's like balanced. I won't really say it really like helped, because there is a things you actually trying to target the people with COVID, and you wanted them to live in the hospital, something like that. So just from my perspective, all my personal experience. So they're good things, they're bad things also.
Okay, so I think that's all about the questions. So thank you for all the answers.
So one more thing I think I forgot to mention for the resources. I keep a couple links here. I think this data set saying like of the data, AWS Exchange, Data Exchange has a lot of data you can use. All of those are actually open source. You can download for free. And here has another package, which is I actually get a certificate, so I'm okay to share.
The slide, right? Lisa?
Yeah, I'm going to provide it.
Okay.
So those are just like you gotta have a lot of Python code already in it, and this is our ML training like courses. So here's the database. So all the information you need probably is already here.
So whoever wants to slide, just email me.
Yeah, I will open up all the link. Make sure I think that you guys have access. So I will share the document, the slides with you.
Okay. So again, thank you, Lisa, for the enlightening talk as well as the answers given. I hope because due to the time we cannot, have more to share, but maybe in the future, maybe we'll set another webinar if possible, right? And hopefully Lisa will come here to Malaysia and give more and more maybe sort of training or maybe talk or workshop and so on, right?
Definitely. I think it could be a training session that's based on one case or something like that. I prepared some cases, but I think it's just like for the time, I don't think we got time to walk through.
Because this data scientist thing needs some, or more
of detail.
Practicality, right? This is just a beginning, this is just introduction.
Yes. All right. I think again, if you like looking for any resources, they're here, and also in my GitHub has all the code and the information in it, so you can take a look.
Okay. So before we end our session, first of all, I would like to say thank you to Lisa Lee Chai Wen, our distinguished invited speaker, for spending her time for us, sharing a lot of things regarding data science and analytics. There is so much to swallow within
Yeah, a
this,
lot of links.
but for me it is very meaningful and very insightful to all of us. I would like to also to thank to the Department of Computer Science and the management of the Faculty of Computer Science and Information Technology for making this webinar successful one. Not to forget a big thanks to the webinar committee, the ICT unit of the faculty, as well as my SSK 4409 Big Data Analytics student. I'm teaching that course actually. All of them are coming. My postgraduate students and all who support this seminar. So before we end, let's just have a quick photo session together with our distinguished speaker. And with all the participants, can all of you switch on or turn on your camera so that we can have a photo session together? Okay. We wait for others to open up their camera. Hold on. Okay, there will be a couple of pages here. Okay, 1, 2, 3, first page. And then next page, we have 3 pages here. Okay. Hold on. Another page. 1, 2, 3. And then the last page. Okay, 1, 2, 3. Okay, so with that, again, thank you, Lisa, for having us.
Thank you for having me.
Yeah, for the webinar, and I hope that everything that is shared within this webinar is beneficial to all of you. And I think Lisa also provide her contact detail. If you have anything to share, anything to ask or inquire, you can contact her. And hopefully she will come to Malaysia to further her study.
Yeah.
Okay, and once she come here, then we will ask her to do a lot of things lah. Training, workshop, blah blah blah. Okay. Okay, so again, thank you to all participants. Thank you, Lisa, and we'll see you sometime in the future. Thank you all.
All right. Bye, guys.
Okay.
Have a great day.
Yeah. Same to you. Okay.